Stars, the celestial furnaces that illuminate the cosmos, each one a distant sun, a fiery testament to the universe's boundless energy. From our vantage point here on Earth, we gaze up at a seemingly eternal tapestry of twinkling lights. But the universe, like everything else, is in a constant state of flux. Even these seemingly eternal stars have a life story to tell. They're born, they mature, and yes, they eventually die. But their deaths, much like their lives, are spectacular events, often seeding the universe with the very ingredients needed for new generations of stars to be born. Over the next few chapters, we'll embark on a cosmic journey, exploring the fascinating life cycle of stars, from their fiery births to their dramatic and often cataclysmic ends. We'll uncover the forces at play, the delicate balance of gravity and nuclear fusion, and the awe-inspiring transformations that these celestial giants undergo. Our journey begins, appropriately enough, in the vast dark clouds of gas and dust scattered throughout the cosmos, the stellar nurseries. These cosmic clouds, often spanning hundreds of light years across, are the birthplaces of stars, the cradles of creation where gravity ignites the fires that will one day illuminate distant worlds. So, buckle up, space travelers. We're about to unravel the mysteries of the stars, those distant suns that have captivated humanity for millennia. Get ready to be amazed by the sheer scale, the unimaginable energy, and the elegant dance of life and death that plays out on a cosmic stage. Our exploration begins in the cold, dark corners of the universe, within vast clouds of gas and dust known as nebulae. These nebulae, often remnants of previous stellar explosions, serve as the cosmic breeding grounds for new stars. Don't let their seemingly tranquil appearance fool you. Within these massive clouds, gravity is constantly at work, an invisible sculptor shaping the destiny of the cosmos. Over eons, gravity draws these scattered atoms and molecules closer together, increasing the density within certain pockets of the nebula. These denser regions, like seeds planted in the cosmic soil, become the focal points for star formation. As more and more material is pulled inwards by the relentless pull of gravity, these regions begin to collapse in on themselves. This gravitational collapse is the first step in the incredible journey from a diffuse cloud of gas and dust to a blazing star. Imagine, if you will, a cosmic snowball effect. As the dense region collapses, its gravitational pull strengthens, drawing in even more surrounding material. This process, driven by the relentless force of gravity, causes the core of the collapsing cloud to heat up. Temperatures and pressures soar as atoms are squeezed closer and closer together, setting the stage for the next chapter in a star's life. This ignition of nuclear fusion marks the birth of a star, a cosmic event billions of years in the making. At these extreme temperatures and pressures, hydrogen atoms, the simplest and most abundant element in the universe, are forced to fuse together, creating helium and releasing an incredible amount of energy. Imagine the energy released by countless hydrogen bombs detonating every second, and you start to get a sense of the power unleashed at the heart of a star. This energy, radiating outward from the star's core, creates an outward pressure that finally counteracts the relentless inward pull of gravity. The star, now in a state of hydrostatic equilibrium, achieves a delicate balance, the outward push of fusion energy precisely counteracting the inward crush of its own gravity. This state of balance defines the longest and most stable period in a star's life, the main sequence. Our own Sun, a yellow dwarf star, is currently in the midst of its main sequence, steadily fusing hydrogen into helium and bathing our solar system in light and warmth. The main sequence is not a static period in a star's life. It's a dynamic equilibrium, a constant push and pull between the forces of gravity and nuclear fusion. The lifespan of a star on the main sequence, and indeed its ultimate fate, is determined primarily by its mass. Massive stars, many times larger than our Sun, burn through their hydrogen fuel at an accelerated rate, leading to shorter but more brilliant lifespans. These stellar giants shine with an intensity that can outshine entire galaxies, but their time on the cosmic stage is fleeting. Smaller stars, on the other hand, like our own Sun, live more frugal lives, carefully rationing their hydrogen fuel over billions of years. These stars, while less luminous, provide a stable and long-lasting source of energy for any planets lucky enough to orbit within their habitable zones. Our Sun, a middle-aged star, is estimated to have another 5 billion years left on the main sequence, giving life on Earth ample time to evolve and flourish. But even the longest-lived stars will eventually exhaust their hydrogen fuel, setting the stage for the next chapter in their evolution, a chapter marked by dramatic transformations and, ultimately, their inevitable demise. Chapter 4. The Aging Star. Running out of fuel. We've spent some time with stars in their prime, radiant balls of fusion-powered energy. But even for these celestial behemoths, time marches on. What happens when a star like our Sun starts running low on its primary fuel? Hydrogen? Imagine a car sputtering as its gas gauge nears empty. A star nearing the end of its hydrogen supply experiences a similar crisis. The outward pressure from nuclear fusion, the force that held the star together, begins to wane. Gravity, always lurking, senses this weakness. The core, now mostly helium ash from spent hydrogen, contracts under gravity's relentless pull. This contraction generates heat, so intense it ignites hydrogen fusion in a shell surrounding the core. This new wave of energy pushes the star's outer layers outward, causing them to expand dramatically. The star balloons into a red giant, a dying ember compared to its former glory. Our own Sun, in about 5 billion years, will undergo this dramatic transformation. As it swells, it will consume the orbits of Mercury and Venus, leaving Earth a scorched, lifeless rock. It's a stark reminder of the impermanence of even the most seemingly eternal objects in our universe. Chapter 5. The Death of a Star. Stellar Endings. After the tumult of a red giant phase, low-mass stars like our Sun face a quieter, more gradual demise. No longer able to sustain fusion in their cores, they shed their outer layers into space, like a cosmic dandelion scattering its seeds on the wind. These expelled layers, glowing with residual heat and illuminated by the dying star's core, form what we call planetary nebulae. Don't be fooled by the name. These have nothing to do with planets. They are, however, some of the most breathtakingly beautiful objects in the cosmos. At the center of this celestial artwork lies the star's exposed core, now a white dwarf. Incredibly dense, a white dwarf packs the mass of nearly a sun into a sphere roughly the size of Earth. Imagine squeezing all the books in a library into a single grain of sand. White dwarfs are the fading embers of once mighty stars. They cool slowly over billions of years, eventually dimming to become black dwarfs, invisible ghosts in the vastness of space. Chapter 6. Spectacular Events in Star Death. The death of a star isn't just a destructive event, it's also a profoundly creative one. As low-mass stars exhale their final breaths, they don't just fade away quietly. They paint the cosmos with intricate and stunning patterns, creating what we call planetary nebulae. Imagine a cosmic paintbrush dipped in the remnants of a star's outer layers, swirling across the canvas of space. These nebulae come in a dazzling array of shapes and colors, from the delicate symmetry of the Ring Nebula to the eerie glow of the Cat's Eye Nebula. But these celestial masterpieces are more than just aesthetically pleasing. They offer us a glimpse into the complex processes at play in the late stages of a star's life. The patterns we see, the delicate filaments and glowing shells, tell a story of stellar winds, magnetic fields, and the interplay of gas and radiation. Planetary nebulae are a reminder that even in death, stars continue to shape the universe around them, enriching the interstellar medium with the elements they forged during their lifetimes. They are a testament to the beauty and complexity of the cosmic life cycle. If planetary nebulae are the graceful swan songs of smaller stars, supernovae are the explosive finales of their more massive counterparts. These cosmic detonations are among the most powerful events in the universe, briefly outshining entire galaxies. Imagine a star, millions of times brighter than our Sun, suddenly unleashing all that energy in a blinding flash. That's a supernova, a shockwave of matter and radiation expanding outward at nearly the speed of light. But supernovae are more than just destructive forces. They are also the universe's primary means of creating and dispersing heavy elements. The intense heat and pressure during a supernova explosion forge elements heavier than iron, elements like gold, silver, and uranium. These newly minted elements, scattered across the cosmos by the supernova's shockwave, eventually become incorporated into new stars, planets, and even life. The very atoms that make up our bodies were once forged in the heart of a dying star, a testament to the interconnectedness of the cosmos. Chapter 7. Stardust and New Beginnings. The cosmos operates on a principle of cosmic recycling. Stars, in their death throes, seed the universe with ingredients for future generations. They go out with a bang, a supernova, scattering elements across space. These elements are the building blocks of everything we know. We are, quite literally, made of star stuff. From the ashes of dead stars rise new stars, continuing the cycle. Chapter 8. Interesting facts about star evolution. Stars live fascinating lives, from birth to explosive death. Our lifespans are but a blink compared to stars. Stars balance gravity and nuclear fusion. Massive stars live fast and die young. They burn fuel quickly, leading to supernovae. Supernovae create fascinating remnants like neutron stars. Smaller stars, like our Sun, shine steadily for billions of years. Our Sun is halfway through its 10 billion-year lifespan. Each star tells a unique story of cosmic evolution. Look up and see stars of all ages, each a testament to the universe's grand cycles. Chapter 9. The Cosmic Ballet. Stars are not just twinkling points of light in the night sky. They are the fundamental building blocks of galaxies, the engines of cosmic evolution, and the creators of the very elements that make up our world and ourselves. From their spectacular births in stellar nurseries to their dramatic deaths as supernovae or black holes, the life of a star is a testament to the power and beauty of the cosmos. We've journeyed through the cosmos, witnessing the birth, life, and death of stars, a cosmic ballet spanning billions of years and countless light years. But our exploration of the universe is just beginning. There's so much more to discover, so many mysteries yet to unravel. So, keep looking up at the night sky with wonder and curiosity, for the universe is full of secrets waiting to be revealed.